All right, let's look at solving some problems using trig. First up, let's look at the standard labeling of a right triangle. When we label the angles and the sides, what we typically do is label the angles with capital A, B, and C is always the right angle. And then we label the sides with lowercase a, B, and C, such that big A and little a are across from each other. Same thing with the others. So the cool thing is, if you've got a right triangle, if you're given one side length and either angle A or angle B, we can compute all the rest of the information about the triangle, the other sides and angles. Notice we're actually given three things because we're given one side length and we're given either A or B for an angle. But we also know that angle C, since it's a right triangle, is going to be 90 degrees. So that's three pieces of information. And we can compute all the other stuff using a handful of tools. We need to know how to use sine, cosine, and tangent. We might need the Pythagorean theorem. And we need to know this fact that the interior angles of a triangle have to add up to 180 degrees. And the other tool you might need is a calculator. So let's do some examples. On each of these, I'm going to draw the triangle. It says a triangle has B equals 15 degrees and C is 100. Find the rest of its measurements. Well, I'm going to start this by drawing the triangle. Let me try that again. So here we go. This is my triangle. Now B, it doesn't matter where I put it, but I'm going to put it right here. B is 15 degrees. I'm going to label it on the outside. So B is 15 degrees and C, that's the hypotenuse, is 100. All right. So let's see. What we know so far is, well, what I've got written there. So let's look at this. This is going to be angle A. This is side A. And this is side B. All right. First up, if B is 15 degrees, and we know that the angles have to add up to 180, that means that A is going to be 90 minus 15. So A is going to be 75 degrees. Now we need to find sides B and sides A. So for side A, well, it doesn't matter which one we do first, but let's think about what we could do here. From B, we could look at side A and side C here and use the cosine. So if I do that, I could say cosine of B, which is 15 degrees, is equal to adjacent, which is A, over hypotenuse, which is 100. So what I've got here is A over 100 equals cosine 15 degrees, or A is 100 times cosine 15. So I'm going to do that on my calculator. I like these little calculators for doing this kind of stuff. I'm going to do 15, take its cosine, multiply that by 100. And that gives me, I didn't say how many decimal places. Let's do this to 2 decimal places. When I do that, I get 96.59 for A. And now what's left? I've got to find B. Now I've got a couple of options for B. I could use the Pythagorean theorem since we already know the other two sides. The other thing I could do is I could use, instead of cosine, I could use sine. Let's do that. So to find B here, I'd look at this and I would say sine of 15 degrees is equal to the opposite, which is B, over the hypotenuse, which is 100. So B is going to be 100 sine 15 degrees. And on my calculator, gives me 25.88. So let's see, that's we got A, and we got the sides A and B. So that's all the other stuff we needed. Let's do a quick check of this. What I'm going to do is, if these two things are correct, then it should satisfy the Pythagorean theorem. So let's do that. What I'm going to do here is I've got 25.88. I'm actually going to clear that out. I'm going to put in 25.88 squared plus 96.59 squared equals this. Now if I take the square root of that, it gives me 99.997. So this is the hypotenuse, and the hypotenuse on the problem, it said 100. So yeah, that's a good check that this is correct. This is of course off a little bit because I rounded those sides. All right, let's do another problem. Another right triangle has A is 49 degrees and B is 17. Find the rest of its measurements. All right, so in this case, I'm going to try to make this triangle sort of accurate. One of these angles is A, so 49 degrees. This is a 90-degree angle. And the other one is going to be, let's see, angle B here is going to be 90 degrees minus 49 degrees, which is, let's see, what is that, 31 degrees? No, 41 degrees. Okay, so B is 41 degrees. That's one of our answers. Then let's see. We've got to find, well, let's label it. Little b that's over here, that's 17. So we need to come up with little a and little c. Tell you what, let's do. Let's find little a first. Now, which trig function can we use for that? Well, let's stick with using angle A. So from angle A, this is the opposite, and this is the adjacent. So what I would do here is I would say tan of 49 degrees is opposite over adjacent. So A is 17 tan 49 degrees. If I stick that in my calculator, it'll give it to me. Now I'll tell you what, let's use this calculator this time because this is probably more like what you guys use. So before I do this, let me see. What you want to do is go to mode and make sure you're in degree mode for this problem. So I'm going to come down here, go over to degree, and hit enter. All right, then I'll quit out of there. All right, so 17 tan 49. When I put that in there, it gives me 19.556. So let's round this one to 3 decimal places. 19.556. And then to get C, we could either use the Pythagorean theorem or we could use B and C. I'll tell you what, let's do. Let's don't use Pythagorean theorem. Let's don't use the Pythagorean theorem. Let's use the numbers that were given to us originally. The thing is, we've got a value for A here, but it's not exact. We rounded it. I do have more decimal places on the calculator, but let's don't use that one. Let's use these numbers that we know are the exact values, 17 and 49. If we use those two and we want to figure out C, what we've got is the angle, it's adjacent, and C is the hypotenuse. So adjacent and hypotenuse, that's cosine. So let's see, cosine of A is adjacent over hypotenuse. So if I multiply this out, I get C cosine A equals 17, or C equals 17 over cosine A. And I don't need to put A there. We know what A is. It's 49 degrees. So stick that in the calculator. 17 divided by cosine of 49. It gives me 25.912. And so that's my answer for C. Little c. Okay, let's check it. What I'm going to do is use the Pythagorean theorem to check it. I'm going to look at, let's see, a squared plus b squared should be equal to c squared. So let's do that. A was 19.556. And b was 17. So if I put those together, I get a squared plus b squared equals this. Now let's look at c squared. C was 25.912. If I square that, I should get essentially the same number. It's going to be slightly different from round off error, but it should be very close, and sure enough it is. So that's a good check on our problem that we do have the right answer. All right, let's stop here so the video doesn't get too long. I want to do a few more application problems, which are going to be very similar. We'll do them in the next video. The only difference is they're, instead of just a triangle, they've got a story to go with them. So we'll do those in the next video.